Hello and welcome to this session of Class 9 Mathematics, and I am your Anu again for MathSchool.1. Actually, today it's triangles and we are going straight into the problems. We have seen some concepts regarding triangles. I hope we have covered all the basic concepts regarding triangles, and let us move today to some problems. We'll see how we have managed to understand the concepts in triangles. Okay, so let us start. We'll do first thing is the angles opposite to two equal sides of a triangle are equal. So we know where are the angles and where are the sides of the triangle, isn't it? So what does the first statement say? Angles opposite to two equal sides of a triangle are equal. Okay, so what do we call a triangle when two sides are equal? We call it as an isosceles triangle, isn't it? When two sides are equal, we call the triangle as an isosceles triangle. So in the case of an isosceles triangle, if two sides are equal, if two sides are equal, we need to prove the angle opposite to them are also equal. This is wonderful, isn't it? So let's try to prove. How do we prove it? Okay, so we have understood the concepts like angles, sides, equal, two equal sides and all the sides are equal, angles are equal, and we have also seen some of the concepts like congruency also, isn't it? So we have done with congruency. So I hope you remember the concepts of congruency. So let us apply some of the concepts in this first statement. Okay, so two sides are equal. Now two sides are equal, they have given you. So the given is, see, you have what is given? Given is AB is equal to AC. Side AB is equal to side AC. Now what we need to prove? To prove is, see, write it clearly what is given and what you need to prove so that you will have a clearer idea. So you need to prove angle B is equal to angle C. So how do we prove it? Now for this, let's do something extra. Okay, so now what I'm going to do is, since these two sides are equal, I'm going to draw bisector of the angle between them. See, I'm going to draw a bisector which lands on BC. So what do we mean by an angle bisector? Bisector is a one which divides anything into two halves, isn't it? So the angle bisector is, it divides the angle A into two equal halves. So these two are equal now. Okay, so the angle bisector has divided A into two equal halves. Okay, so this angle bisector means the side of the triangle BC and D. Okay, so now what do we have? See, after drawing the angle bisector, I have divided the whole triangle into two triangles. See, there are two triangles for you. Let me write triangle ABD. Always follow the same order. Okay, whenever you name the triangles, regarding the congruency, we are going to see congruency step by step in this chapter. So whenever we name the triangle, whenever we say two triangles, which are going to be compared according to the congruency criterion, the naming is very, very important. The order you name the triangle is very important. So ABD, I've named ABD. A triangle is ABD. The next triangle is ACD, in the same order which we have named, by which we have named the first triangle. So the triangle ABD and triangle ACD are the two triangles now because of the angle bisector I have drawn there. Okay, so now after drawing the angle bisector, I know, see, the angle, these two angles are equal. So let us write that too. Angle BAD. See, which is angle BAD? BAD. And the angle CAD. The angle CAD, they are equal, isn't it? Because it's an angle bisector, it divides the angle into two equal halves. So these two angles are equal. Now see, what are the things we have? We have, the given is two sides are equal, and we have constructed an angle bisector so that these two angles are equal. The angle BAD and is equal to angle CAD, isn't it? Now let us do this. So first thing is the side AB is equal to AC. Okay, the angle, this is given actually, you need to write it, you need to justify whatever statements we write, you need to write the justification also. Next is angle BAD is equal to angle CAD. This is by construction, because we have constructed an angle bisector. So this is by construction, it is equal. And see, for both these triangles, the line, the side AD is common, isn't it? So AD is equal to AD, because this is the common side. Now, so let's see what we have written. AB is equal to AC. This is a side of the triangle. This is the side of the triangle. This is the corresponding side of the triangle. The corresponding word is very, very important. You note it down. So AB is equal to AC. The corresponding sides of the two triangles are equal, and the angles, the corresponding angles are equal, and this is the common side. So that becomes the corresponding sides of the two triangles, and that is the, since being the common side, that this is also equal. So what is this? This is a side, this is one angle, and this is one side. See, look how easily we have spotted which criterion this belongs to. So this belongs to SAS criterion. SAS, side, angle, side. That is two sides and an angle enclosed between two sides. Okay. So this is the criterion under which we have made these two triangles, triangle ABD and ACD, to be what? To be congruent. Okay. So according to CPCT, that is corresponding parts of the congruent triangles. Since we have proved according to SAS criterion these two triangles, see, triangle ABD and triangle ACD, to be congruent, so we need to write triangle ABD is congruent to triangle ACD. Since these two are congruent, what happens? According to CPCT, the corresponding parts in the congruent triangles, we have 6, isn't it? We have 6 parts. What are they? 3 sides and 3 angles. Okay. So the corresponding parts, the congruent triangles, are equal. Since according to CPCT they are equal, we have angle B also equal to angle C. So therefore angle B is equal to angle C. So by SAS criterion, if we prove the two triangles to be equal, then all the parts of the congruent triangles are equal to corresponding parts. Okay, so thereby angle B is equal to angle C. So what happens? Coming back again to the statement, angles opposite to two equal sides. See, these are the two equal sides, and the angles opposite to them are equal. So this is universal. You need to keep it in your mind. That is, when two sides are equal, the angle opposite to those two equal sides will be equal. Do you understand? Yes, this is clear now. Now we'll do some problems related to this statement. Okay, to understand this statement very well. So let's move on to the next problem. Given AB is equal to AC. So here you are given with two equal sides. So immediately what I need to do is, I need to mark the angles opposite to those two equal sides which are equal. So these two angles are equal, right? Yes. So these two sides are equal. So these two angles are equal. So that we know. Okay. Now what is the extra detail they have given you? So they have given you ACD 120 degrees. Now what is ACD? We know, we have studied about it. This is the exterior angle. So the angle which is the exterior region, and when one of the sides is extended and the angle made in the exterior, isn't it 120 degrees? So this is 120 degrees. Now what they have asked you? They have asked you to find A, angle A. It is quite easy, isn't it? Because see, we know these two angles are equal. If we know the measure of this angle, then we'll be able to find out the measure of angle A according to angle sum property, because we know the sum of all angles in a triangle is 180 degree. So just we need to find this angle. So this is very easy because this is in a straight line. In a straight line, if there are two adjacent angles, it forms a linear pair, we know. So given 120 degrees, so what is this angle? You can say this is 60 degrees, because 180 minus 120 will give you 60, because angle C and angle ACD forms a linear pair, isn't it? So 120, this is 120, this is 60. Obviously, if this is 60, this is also 60, isn't it? So if this is 60, see, these two angles are equal, we know, because these two sides are equal. So if these two angles are 60, what is this angle now? So we know, according to angle sum property, according to ASP angle sum property, we know angle A plus angle B plus angle C is equal to 180 degrees. Now B and C are 60, isn't it? So what is angle A now? Angle A plus 120 is equal to 180, or A is equal to 60 degrees. So this is also 60. Now do you understand? So this can be done according to another property also, which is the exterior angle property. Yes, we have done before, isn't it? Exterior angle property, what does it state? The exterior angle is equal to the sum of the opposite interior angles, isn't it? So sum of the opposite interior angles is, see, one of the angle we know it is 60. So 60 plus what gives you 120? So it is obviously 60. Or we can also check 60 plus 60 is 120. So it holds good for the exterior angle property also. So our answer is right, isn't it? So 60, 60, 60. Now can you say another thing about this angle, about this triangle? See, this triangle has all the angles equal. If all the angles are equal, it is an equilateral triangle, isn't it? So in an equilateral triangle, not only the two sides, those two sides are equal as it is given, not only the two sides are equal, this side is also equal. So all the three sides of this triangle are equal, because all the angles are equal here, isn't it? So we'll be able to do, if we try to analyze each and every part of the triangle, we'll be knowing better and better, isn't it? So this is an equilateral triangle and all the sides are equal. Okay, so now do you understand how did we arrive at the answer? Yes, please take a note of it. We'll move on to the next problem. Now the third one is, prove that the measure of each angle of an equilateral triangle is 60. So what we have done before, it is also an equilateral triangle. So we have we have found out it is 60 degrees by using the exterior angle property, and two sides equal they have given you, and we have followed the first statement, isn't it? Now we need to prove in a triangle the measure of each of an equilateral triangle is 60 degree. Now we need to prove the measure of each angle is 60 degree when it's an equilateral triangle. Okay, now we'll start doing it. What is an equilateral triangle? I told you before, when all the sides are equal, it is termed as an equilateral triangle, isn't it? So AB, AC, BC, all the sides are equal. Now let us take first these two sides. Let us take these two sides. Okay, any two sides. So let us take AB is equal to BC. Now we know, according to the first statement, if two sides are equal, then the angle opposite to it are equal, isn't it? So if AB is equal to BC, then the angle opposite to AB is C here, and the angle opposite to BC is A here. So which means angle A is equal to angle C. Okay, so which means angle A is equal to angle C, because AB is equal to BC, so the angle opposite to these sides are equal. Okay, so the next we'll take the two pairs. AC is equal to BC, because I said all the sides are equal in an equilateral triangle. AC is equal to BC. Now what does this imply? AC is equal to BC. See, the angle opposite to it is B, isn't it? So AC opposite to it is B. See, this is B, and BC's opposite angle is A again. So angle B is equal to angle A. Now what do we have? Angle A is equal to angle C. and angle B is equal to angle A. So B is also equal to angle A. So I can write it like this. Angle A is equal to angle B is equal to angle C, right? So all the three angles are equal. By these two statements, I can write angle A, angle B, angle C are equal to each other. So now, according to angle sum property, we know angle sum property, angle A plus angle B plus angle C is equal to 180 degrees, isn't it? So now I replace angle B and angle C by A because all the three are same. So I have angle A plus angle A plus angle A is equal to 180 degrees, that is 3 times angle A is equal to 180, or angle A is equal to 60 degrees. So that is how we prove angle A is equal to 60 degrees, that is each of the angle, because since angle A is, we have proved that angle A is 60 and we have angle A, angle B and angle C all are equal here. So all the angles are 60 degrees. So the measure of each angle in an equilateral triangle is 60 degrees. Do you understand? So just keep in your mind, angles opposite to two equal sides of a triangle are always equal. Please don't forget that. So remember the statement, and we have seen the statement and we have solved problems according to it. Two problems based on the statement. Okay, so in the next episode we'll be solving some other problems. Okay, so we'll start solving problems and we'll get to know what our triangles are. Okay, thank you. Bye for today.